So from the beginning, we launched the thing. I'm going to call this project RPG Systems. So we're going to do RPG Systems is the name of the project. This is going to be a C++ project. Um, I'll take the starter content. I don't know if I'm going to use it. And then I always do third person. I don't know. I like third person games. It doesn't really matter. You can do first person top down. The style of game doesn't matter. So now that we're in our project, it's loaded up and it's started, I'm going to handle the first few couple administrative deals. We're going to go into edit, come into the editor preferences, and we're going to do a couple things. One, the asset editor open location, I'm going to put in the main window. So when you open anything, it just opens a new tab. That's the first thing. The next thing is I'm going to come to live coding and I'm going to disable live coding. The next thing I'm going to do is type hot reload, and in the hot reload automatically compile newly added C++ classes. You're going to uncheck that, and then we're going to take care of that, and then we're going to come into the plugins and we are going to do gameplay abilities, and then you must restart and then restart. Okay, now that we have that, I'm going to come back into here, and I'm going to take this JetBrains writer. I use writer. You can use any system you want. Doesn't matter as long as you copy the code like I type it. But I'm going to open it up in writer. Trust and open so it can start loading and indexing. The first time you start a project and it has to load an index, it takes a while. So I'm going to get that going in the background. Okay, we're back. I cut that out because that took forever to index. But so now that we've got everything loaded up and initialized and everything's up there. So we're going to come to games, source, RPG systems, and excuse me, expand that a little bit. We're going to go to the build.cs. We need to add 3 things to this public dependency module name. So we're going to do this, and it's going to be gameplay abilities. And then the second one we're going to need is gameplay tasks. And then the third one we're going to need is gameplay tags. After you do that, build. Okay, build successful. So now that we have that, first thing I'm going to do is this character file is a hot mess. So we're just going to come here real quick. I'm going to get rid of all of these comments. I'm going to leave all the input actions here for now. I don't need to, excuse me. Come back into the C++ classes and the RPG, and first thing we're going to need is this is a multiplayer game, so we're going to need to put the ability system component and the attribute set that are the primary components of gas. We're going to need to put it on the player state because the persistence level of the player state lasts longer than the actual player itself. So if the player dies in game, you don't want the ability system component and the attribute set destroyed, or maybe you do. If you want it to destroy with the player, then put this all on the player. But in the multiplayer version, you want it on the player state. It's also replicated by default in the engine, so there's a bunch of stuff already handled for the replication for the player state. So just putting it on here is a free mechanism to be able to handle all the ability system and the attribute set. So we're going to make the RPG system source public. I split mine public private folders, and we're just going to say this is going to be in game player state in that module. Create class. Yes, I'd like to do that. Don't open because this will sync the project. And then the next class I'm going to want is going to be an ability system component. We're going to want that. and it's going to be an RPG ability system component, and this is public, and we're going to do ability system, and we could just leave that in there, and then we'll open that. The last class I want to make is an attribute set, and we'll just call this RPG attribute set. This is public ability system attributes. It keeps yelling at me to open this one up, so I'm going to open this one up and see if it just wants me to load this file version, and if this takes forever, then I'm going to just break out and I'll be back when this is done loading. Okay, so now that we have everything loaded up and we're finally set, ready to go, we can open the header file, the player state. Inside the player state is where we are going to keep the ability system component in the attribute set, which means we need to make a public section, and in the but first off, the first thing we should do is inherit from the public iAbility system interface. Writer auto included the ability system interface header for me, so don't forget to do it if you're not using Writer, but Writer just gives it to you. Now that we're inheriting from that interface, there's only one function on it, but it's required to be using gas, and that's a virtual void uAbility system. Oh, not virtual void, virtual uAbility system component pointer get ability system component with a const override. Okay, so that's the interface function, and you're going to have that. But the thing is, before we can do any of that, we need to have a tObject pointer for, we're going to use our inventory system component. We're not going to do a base one. So we're going to use the uRPG ability system component that we're going to add a forward declaration for. And this will be RPG ability system comp for that. Now this is going to get a U property, and we could say blueprint read only. And because of that, you'll need meta equals allow private access set to true. Now, blueprints can read that. Now, the second thing it's going to need is the tObject pointer for the uRPG attribute set. And we're going to add a forward declaration for that, and this is going to be RPG attributes. And this is a U property, blueprint, blueprint read only meta equals allow private access equals true. Now we've got that. Now we also need, in order to set these up, we need a constructor. So I need an a RPG player state constructor. And we can do this now. We can generate definitions for both of these. Writer generates definitions fully qualified. So now all we have to do here is in the interface function is return our RPG ability system component because it inherits from the regular ability system component. And we're going to get an error because, of course, the first thing we did not do is include the it's in ability system RPG ability system component. So now it knows that that's a uAbility system component. So our error goes away. So back in the constructor, the first thing I'm going to do is say that I'm going to change these two settings for that. I don't find that we change these settings very frequently. However, if this is an RPG that's going to have like player versus player combat or anything else that needs quick changing attributes constantly in the multiplayer space, I like to increase the net update frequency, the per second updates over the network, specifically for the player state. I don't do it for very many other things. The default values is usually fine, but on the player state, because it is handling and it owns the ability system component and the attributes, I just like to update the net frequency there. So we're going to say the net update frequency, and we're going to set that equal to 100.f. And then we're going to take the min net update frequency and set that equal to 66.f, so that no matter what, at least the target 60 frames a second is going to get an update. And then after we have those set, then we can take the RPG ability system comp and we're going to make that. So we're going to say equals create default sub object of a U RPG ability system component. And we're going to set that name to ability system comp. And then I just call RPG ability system comp and I say set is replicated and set that to true. And then because this is multiplayer, you need to you take the RPG ability system comp and then you set replication mode. And for multiplayer games, for actual players of a multiplayer game, it is an E gameplay effect replication mode mixed. That's the setting you want. You want the replication mode full if you're doing a single player game. And if your ability system and everything is on an AI, then that is when you use the replication mode minimal. So for the actual players, we're going to do mixed. And then for the RPG attributes, we're just going to go ahead and set that to create default sub object of a URGB attribute set, which we're just going to call attribute set. And if you notice, writer auto included the header file for the attributes, so you need to do that. Don't forget to do that. So now that we have those, I also see, here's the thing is we have this generic that you required interface getter for the ability system component. However, I will tell you that what I like to do is take an URPG ability system component returner and then say get RPG ability system component. And then that can be const. And then I like to say URPG attribute set pointer get RPG attribute. Yes, const, excuse me. And then what you can do is actually make these U functions and say blueprint here. And then we are going to generate definitions for these. And all we need to do is return RPG ability system component again, and then return RPG attributes. Get your semicolon. So now the player state owns the ability system component, and we have all the getters to get all this stuff off of it, right? So what do we do with this now? Well, we can close the player state for a second, and we can come back to their character, and we're going to come in the character file. And in the character file, I don't have a private section, so we're going to make a private section. And force inline getters, I leave at the bottom of the file, so we'll just leave those down there. In here, we're also going to make a T object pointer of a U RPG ability system component forward declaration RPG ability. Ew, gross. Ability system. I just say comp. And this is the U property blueprint read only, which is meta equals allow private access equals true. And then we have another T object pointer of an URPG attribute set with a forward declaration that we call RPG attributes. And we make that U property blueprint read only meta equals allow private access equals true. Great. Now we have that. We're going to need some virtual overrides because we need the timing of these functions. So virtual possessed by is the first one, that override, and then virtual, we're going to do on rep player state. Remember, we're doing this multiplayer and we put it all in the player state. So that being said, we're going to take it here and we're going to say void. We're going to make a function called init ability actor info, and you're going to need that because you have to do that. So I'm just going to come here and generate definitions for these three functions. Now, what do we do in an ability actor info? Well, we're going to say if an a RPG player state pointer, and we say RPG player state, and we're going to set that equal to get player state. And if you do the templated version, you can just say a RPG player state, and it returns you the casted version. So once I have the player state, what I can say is RPG ability system component, set that equal to the RPG player state, and then now you can just call get RPG ability system component, and then you can do RPG attribute set again, the RPG attributes, you can do the RPG player state, and then you can call get RPG attributes, right? So now you have those filled in, and then we can say if is valid RPG ability system comp, and look, I can't is valid, which means it's not recognized as a valid U object, which means I didn't include ability system / ability system component, and now that I did, now it's recognized as a U object. So now that if it is valid and I can pass through that, then I take the RPG ability system component, and I call just the same function, init ability actor info, that's built off to that. However, this one requires two parameters. The first parameter is the owner actor, and the owner actor is who owns the components, which is the RPG player state. The second parameter is the avatar actor, which is the physical actor of the physical representation of the ability system component in the world space. So that's the player, which is this. And then there, now we have init ability actor info. We need to call this so the system is registered. And then simply in possessed by is a perfect time. If you have authority on the server, at that point you can init ability actor info. But you want to wait until the on-rep player state, so you know this rep notifies on the clients, right? And then you know now this is the earliest time that the player state is valid. So if you know the player state is valid here, then you can just say init ability actor info, right? And then you don't have to worry about authority checks because it's a rep notify. It's only on the clients anyway. Okay, so the first thing I'm going to want to do is test. I want to know that I've got server and client ability system component attributes. I want to make sure just this basic setup is working on there. So what I need to do is establish back in the ability system, in the ability system component attribute set.h. What we're going to do is come here now in your attribute set. How you set it up for a little bit takes a second right here. What you're going to want to do is go into the attribute set parent, right? Go to the declaration or uses, and in this header file, the macro, right? This is the macro magic that Epic does right here. But the cool thing is if you just copy these right here, and then you just come up here and you paste them, and you get rid of these, get rid of that, get rid of that, get rid of that. So now that I have that, when I get access to these macros, and the greatest part is it gives me getters, setters, and initers, and attribute getters, and it gives you a whole bunch of utility functions for all these attributes. And it's just for free. Epic helps us. It's great. So the first thing I'm going to do is make a public section, and we're going to test it with just, let's start simple. These are not floats. Gameplay attributes are a special variable in F gameplay attribute data. That's what it is, and we're going to call it help. And then you're going to take a U property, and you're going to say blueprint read only, and replicated using equals on rep help, right? And then right here, right underneath it, you're going to do the attribute accessors macro, right? And then you're going to say U RPG attribute set, and what you're doing is health. Now, the sad thing about attributes is it's literally just a bunch of copy paste. So, uh, also, gas does not have an easy way to differentiate between like health and max health or mana and max mana. They don't have an easy somewhere that you can just put in a box. This is my max. So max values for attributes are attributes in and of themselves that you must maintain separately if you want to do this. So now that I have those, I need a private section for the rep notifies, which is on rep health. And it's going to give us, remember, it's going to give us an F gameplay attribute data. It passes by const reference and it's just called old variable name, right? And it needs a U function specifier. And then I need an avoid on rep max health and then const F gameplay attribute data, and then I can say old max health and mark that with a new function. And then keep in mind that's max health right here, not health. So those. I forgot the biggest thing. Everybody forgets this. Everybody forgets this. You must include ability system component.h for any of this to work. You must include that. Everybody forgets that. I don't know why. It's just so common to forget. Gotta include ability system component in your attribute set. All right, so also the next thing we need to do is write out the virtual override because we're going to replicate here. We need virtual void get lifetime replicated props. And then we're just going to define definitions for these. And then, excuse me. So my rep notify is going to be a do rep lifetime condition notify. And it is going to, the class is the URPG attribute set. You're replicating health with the condition of none. And you're doing rep notify always. And then you're going to do rep lifetime condition notify again. URPG attribute set max health condition none rep notify always. Now, once you do that, Epic has given us more macros to make this even easier. Your rep notify simply needs to be gameplay attribute rep notify, passing in URPG attribute sets. We're replicating health, and then we need to pass in the old health as well. And then you just come back and do the same thing. Gameplay attribute rep notify URPG attribute set for the max health, and then old max health. Okay. Now, I also need to we're going to do one thing to kind of set ourselves up just one little time. It's another virtual override. It's going to be virtual void, and this is going to be called post gameplay effect execute override. And we're just going to generate a definition for this real quick. So how I'm going to start off, this is going to get refactored because this, when you first start, this this function is pretty small. But as you get deeper into a game, this function can get out of hand and really bloated really quick. So we're going to start the quick and dirty way, but this is guaranteed refactor later. So what we're just going to do is if data.evaluatedData.attribute is equal to get health attribute, that function, that get health attribute, is because the attribute accessor's macro. So it's just there now. We have it, right? So then we're also just going to have the rest of these magical functions. You can set health to an fmath, clamp, and you're going to clamp what the current value get health is, and you're going to want to do that between 0.f and get max health, right? You want to clamp health between what the current value is between 0 and f. There you go. We're just going to set that up for now so that no matter what, while we're testing this, we're going to make sure that our health stays within bounds that we label. So now we have the ability to modify. We have all that. We have this. Check, 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 right? Let's take a second real quick. Everybody just build just to make sure everything builds out fine. Let's take a second and build. I want to close the project and rebuild in debugging mode for a second, just so I could see the folders. Oh, I don't. Okay, so now that we rebuilt and we're in uh, debug mode and we have our C++ folders. Here we go, public, ability system, game. Okay, so what are we gonna do? Let's make another C++ class. We're gonna do, I need the data asset, and then I already have the ability system component. Looks like I also need the game mode, however. So we're gonna need two classes next, right? We're going to need just a data asset, and we can call this character class info, and this is going to be in public, and this is going to be data. And we're going to open that. I can get rid of the rest of these tabs for a second. And then I need to come back in the game, and then there's the player state. But what I need is, that is a game mode base. We don't want a game mode base, right? We're going to do multiplayer, so we're going to want just the regular game mode class that's got that more functionality. So we could say RPG game mode. Create this class. Okay, so what are we going to do here? Well, we want this data asset because we're going to do something. We're going to do something using gameplay tags. I like using gameplay tags in as much as I can. They're very cool, very flexible. They'll, if you organize them properly, I always say you can run your whole game off them because they're just so useful in so many mechanics. So we're going to need a struct. This is character class information. So we're going to make a U struct, and it's going to be f character class default info. That's the name of that. And the first thing is going to be a T subclass of U gameplay effect that we're going to add a forward declaration to, and then that's it's going to be called default attributes. And this is going to be a U property edit defaults only. And then the next one we're going to want is going to be a T array of a T subclass of U gameplay ability with a forward declaration. And don't forget your second bracket. And this is starting abilities. And we're going to do a U property edit defaults only. And then the third one, we're going to just do 3 right now, is a T array of a T subclass of U gameplay ability with the second bracket called starting passive abilities. We'll just say starting passives. And we'll say U property edit defaults only, right? Okay, so now that we have this struct that we're just going to put all this like default info, the only thing we need to do in this data asset is make a public section, and we can make a T map that's going to measure versus F gameplay tags, which you have to do the include. You can't do a forward declaration on the gameplay tag. You need to include the gameplay tag container.h if you want to use it. And then it's going to be a map of F gameplay tag to F character class default info right here. And this is class default info map. And this is a U property edit defaults only. So now that we have this map that's going to do gameplay tag to character class default info map, now what we're going to do is come into the game mode, and this is now a game mode here. So what we're going to do is make a public section and a private section, and in the private section it's going to be a T object pointer to a U character class info that we're going to do a forward declaration, and this is class defaults, and this is going to be a U property edit defaults only. Category is going to be custom values. class defaults. Why not? So because we're going to make it private though, we're going to need a U character class info pointer return get character class default info const, and we can make a return class defaults. Okay. So, however, I would like to keep this. The game mode only exists on the server. However, I would like to get a more abstract getter for this character class default info than just I need a more abstract version than just getting it directly off the game mode. So what I'm going to do is come back into the RPG systems. I'm going to come into my C++ classes, and in RPG systems public, I'm going to create a new C++ class that's going to be a blueprint function library. And this is just going to be a static function library. And we're going to say RPG ability system library. And this is going to be in public libraries. And then we're going to edit this class. And oh shoot, I don't want to start closing those. Okay, so this needs to be in a public section, and it's going to be a static function, right? So we're going to do static U character class info with a forward declaration pointer get character class default info, and we're going to need to take in a const U object pointer called world context object. Don't forget that. And what we're going to do is label this as a U function, and we can say blueprint pure, because this is a const function, so I can make it blueprint pure. So now that we have that, what I could say is we could say if a RPG game mode pointer RPG game mode, and we're going to set that equal to a cast of the ARPG game mode, and we're going to cast that onto the U gameplay statics version, don't forget to include, of get game mode, and that requires a world context object. So if I do that and I get a valid game mode, all I have to do is just return RPG game mode. We can call the function get character class default info, right? And if the problem is if that's not going to happen, we just need to return a null pointer. Hope it's not null. May the compiler ever be in your favor. Good news, you can make this const. What a bonus. Okay, so now I have this ability system library static function, right? So now I can do this. Now I want to come onto the player. Excuse me. We're going to come onto the character. And in the private section, I am going to make another variable. And this is going to be a variable of an f gameplay tag that, again, we need to do the include for. We can't do the forward declaration. This is going to be an f gameplay tag that we're going to call character tag. Okay, and this will be a U property edit. We're going to do edit anywhere on this one because if you edit defaults only, then you can't edit world placed instances. But if for some reason you want to be able to place characters in the world instead of spawning them in, and you want to place them in, the ones that are placed in, you have to require edit anywhere instead of edit defaults only. But we're still going to put it in the category of custom values character info. So now that we're going to say that this player character has this character tag, right? And we're going to init ability actor info. We can also just do another void function that's going to be init init class defaults. the character tag. So what happens in init class defaults? What's going to happen is we're going to check if not character tag dot is valid. So we're just going to UE log temp warning, and we're going to say text no character tag selected in this character, and then the type specifier for a string, and then we come back out here so we can do the cast get namesake, passing in this, right? So then if they don't have a character tag selected, we're just not going to do anything because we're not going to be able to access anything. Then we're going to say else if I can grab the U character class info, which you gotta see where it auto included the header for me, so don't forget if you need to. If I can get this class info, I'm going to set that equal to, we now have the U RPG ability system library. Don't forget to include that header. And then we have the get character class default info. And the world context object can just be this. So if this is real, which means now this is on the server, right? Then I can do this and I can say if there is an F character class default info, which this is going to be a pointer, and this is going to be the selected class info, and we're going to set that equal to, now that I have the class info pointer, right, I can get into that class default info map and call find, and remember the keys are gameplay tags, which are just going to be character tags. So that'll return that selected class info, and I guarantee you this is about to be a const pointer. Now, holy cow. So now I have this struct, and it's got default attributes, starting abilities, and starting passives. So let's hold up for a second. Let's figure out what's going to go in here. I want to be able to use all that. Let's go do that in here first before we try to move on to the next part, which means I'm going to need to come to the ability system component itself, and we're going to need to make some public functions. And the first one is going to be void add character abilities, and this is going to take in as a parameter a const t array of p subclass of u gameplay abilities. That, don't forget the second one by reference that says abilities to grant. Then we're going to need a second one that's void add character passive abilities. That's also going to take the same const t array. Boop. We could just go ahead and do that. And we can say passives to grant. Passives to grant. And then we need a third one, which is going to be void initialize default attributes, and this is going to take in a parameter of a t subclass of u gameplay effect, right? That's the attribute effect. So this is how we give yourself default attributes, is through an attribute effect. I'm going to generate definitions. So in add character abilities, we're going to need to grant the abilities from the ability system components. So what we're going to say is for, because we have an array of these abilities to grant, so we're going to do a const t subclass of u gameplay ability, reference ability, and this is going to loop through the abilities to grant, right? We're going to need to make an f. Oh, excuse me, I'm going to work backwards. Working backwards is a lot easier than trying to remember how to go through it forwards, in my opinion. So we need to give ability. Now, that needs an F gameplay ability spec. And then how do you get that? You do f gameplay ability spec, and you can say ability spec and set that equal to, you just construct one, f gameplay ability spec, and then you just build it with parentheses, and first thing it needs is a T subclass of the gameplay ability. So we just pass an ability, right? So we're going to give it the ability. And then this is up to you, but I do my defaults at level 1. Maybe we can look into later how to expand that to be more flexible than just hard coding and give it to you at level 1. Maybe I could do that, but let's not try to get too much into that right now. So we're going to give the ability with the ability spec. Nope, spec needs the spec. Okay, so for now, all those in there, we're just going to give it to them. And then add character passive abilities. We're going to kind of do the same thing. So what we're going to do is just copy this real quick. We're going to paste that here, but we're going to look through passives to grant. And then instead of calling give ability, the function is give ability and activate once. And you still do that with the ability spec, however. So give ability and activate once, and then that's just going to activate and run the passives. So initializing default attributes is just going to be the native functions to apply a gameplay effect to yourself. So how I'm going to do this again backwards. So what I'm going to do is start by saying apply gameplay effect spec to self. And then I'm going to look at the type. It needs a gameplay effect spec, and a gameplay effect spec is found inside an f gameplay effect spec handle that we're just going to call spec handle. And we're going to set that equal to the function make outgoing spec. Now the spec needs a T subclass of the gameplay effect class, and that's the attribute effect, right? And then default attributes, I do always hard code level 1. The third parameter is an f gameplay effect context handle. So how do you get one of those? You just say f gameplay effect context handle, and we can just call it context handle, and you set that equal to make effect context. Isn't that convenient? And then you can just do that and take your context handle and put it in there. And then it's going to yell at me that these two can be made const. So let's go ahead and just make these consts. And now that we have that, now we're going to apply the gameplay effects back to self. So we're going to need to make sure we dereference, and it's found inside the spec handle. There's a data right there, and we need the pointer. So we're going to call get. And that's how you apply the gameplay effects back to yourself. But what we should really do, is say check. Let's make an assertion. So check F. Let's make an assertion that the attribute effect is valid. And if not, what we'll do is take the text and say no valid default attributes for this character. And then you can still do the type specifier for a string. And how we're going to get that is still need the casted. We're going to say get avatar actor, and you can do get name, and that's it. And what that'll do is just kind of crash the engine if nobody gives you default attributes. So I know that if it gets past that line, those are going to be valid and it'll be fine. Oh, it looks like I didn't pass it by const reference here. It doesn't like that. So let's go ahead and back up and do a little proper things. Thank you, Ryder, for reminding me that I can do these things. Const, gonna just do a little optimization, just the little things. Const reference. There we go. So now we're gonna initialize default attributes with that. So now we have those three functions. Here we go. Now we're going to come back into the character, and we can go if is valid, and we're going to check the RPG ability system component, and if that is we're just going to start calling those functions we just wrote, right? Add character abilities. Now where's this array of abilities? Remember, it's in the selected class info, the starting abilities. And then we're going to do RPG ability system component. We can add character passive abilities, which is still in the selected class info in the passives. And then we can do RPG ability system component. We can say initialize default attributes because that's also in the selected class info. The default attributes is right there. So now we're going to be able to use gameplay tags to be able to define our character classes. And I think with that being said, where do I need to init class defaults? Oh yeah, here we go. This would be a great place. I've got the attributes, I've got that, I've got that. I know for a fact the rest is going to be balanced, so I might as well just call it right here. Init. Oh, excuse me. Because remember, this class info, this is coming off the game mode. You only want to do this one now on the server. So we're going to check right here if has authority. Then we're going to init class defaults. If you let the clients init class defaults and they have a valid character tag, this is going to crash. It doesn't like it. It doesn't like it. So we're just going to if has authority init class defaults, and then whatever we apply to the server that happens on the server, it'll just go ahead and replicate down to all the clients. So it'll look fine. It'll look smooth. No problem. So let's go ahead and we're going to rebuild, recompile, and go into the editor, and let's start pumping out some of these blueprints. We need some of these data assets. Build succeeded, by the way, excuse me, I didn't see it. Build succeeded, and it's going to load up the editor. Okay, so now that we're back in the editor, what are we, man? We made all these things, right? So let's come into third person. Let's go into blueprints. Here's our character. So we're going to make one called player, and we're going to put him in here. And we're going to make one call. Oh, no, I don't need that yet. We're going to need a folder, and it's going to be ability system. And then we're going to need a folder, and we're going to call it data. Excuse me. And then we're going to need another one, call it game mode. And in the player where I've got that, you could do folders. It's up to you. I don't mind this how it is. Let's start by making a class in the player. The first one we're going to do is a player state, but we need to do the RPG player state, remember. So this is just BP RPG player state. And you don't need to do anything because all of our values are all set inside C++. So then we're going to make another class. Oh, excuse me, I don't need to make another class yet there. I just need that. Oh no, excuse me, I need a game mode, and this is an RPG game mode. So BP RPG game mode. I'm going to come into the RPG game mode. I am going to set these values, however. Now, before I do it, this is the first one I do. If you want to know this little fun thing that's going to prevent you from losing your work, if you don't know about this, push these three little dots next to compile. You got save on compile right there. You just go ahead and click on success only. And now every time your compile button works, it will save it for you as well, so you stop losing data and forgetting to save. So now that we got that going, player controller, player state, let's go ahead and do the BP RPG player state. Default pawn, we're just going to use the BP third player, and we're going to set that there, make sure we're good. That should be fine for now. That should be fine for now. And then we've got the game mode. Oh, excuse me, make sure we come into the world settings and override that with the RPG game mode. And then in the data, we need to come into miscellaneous. And, oh, excuse me, before we do that, we're going to come into the ability system, and we are going to make a new folder called attributes because I need to make a blueprint class called the gameplay effect. And the prefix is always GE in gas, gameplay effect, and this is going to be GE default starting attributes. Now, in default starting attributes, it's going to be an instant duration policy, right? You want it to be an immediate permanent change. We're going to need two modifiers, and we need two for a reason, because remember that in the post gameplay effect execute, we set health and we clamp it between 0 and max health. Well, in the world of gameplay effects, The order of operations matters because it modifies your attributes completely and fully one at a time. Meaning, if you just throw health in here and then max health and don't care about the order of it, if you do it this way, your game will load and you will always have 0 health, but you will get your full max health value because you are clamping between 0 and the value of max health, which when you are modifying health first is still 0. So in the world of these attributes where you have max values versus regular values, you must always award the max value first before you award the value. And I'm going to override. I'm just going to override it to 100. And I'm going to override it to 100. Right? So now that I have default starting attributes, now I can come back into data and I can come into miscellaneous and I can make a data asset, and this is a character class info. There it is. I'm blind. DA character class info. And then remember, all we have is this default info map. So we're going to add one element. Oh, look at this. We have a gameplay tag. Well, I don't have any gameplay tags. Well, the good news is we just come in here. We can add a gameplay tag. And it's character tag, right? Remember, we need a character tag. So we say character.player.default. Give it some kind of layers. And you're going to add it to the default gameplay tags and add new that tag. Okay. So new tag. Now we've got character player default. Now I've got that. And we've got that struct, right? So we're going to set the default attributes as the GE default starting attributes that we just made. And we don't have any starting abilities and passives yet. That's going to be down the road. We'll take care of that when we get into actually doing some abilities and passives and stuff. So let's, for right now, make sure we got all of our stuff tested and working. So we got default starting attributes. We got that class info, which means we need to come back into our player. And in the custom values, in the character info, they've got the character tag. We got to make sure that we do the character.player.default, remember. And then I compile, but then because I compile, it saves on success, so it does that, so I'm automatically saving, right? So how do we test this? Let's see. When I hit play, there's going to be this cool... We're going to do this. You don't know how much health I have, but if you open your console commands and you type show debug ability system, it has no prompt, but it's just show debug ability system. You hit go and it pops this up. And now you have, you can see over on the left, I have health, and health is 0 and max health is 0. So we've got an issue somewhere already. Right? How can the health be 0 and the max health be 0? Well, look at this. Do you think on the game mode I forgot something? Don't you think? Anyone realize what I forgot on the game mode? We store the class defaults on the game mode, and I never put the class defaults on the game mode, right? So it has no idea. So now let's give it a shot with our show debug ability system. There is, however, before I go, I forgot to show that this works in multiplayer. However, I'm only testing single player. So let's load 2 players and let's play as clients. So now we have 2 players. Now let's try to show debug ability system. And now local player simulated, you can still see up here, right here, local player simulated has 100 health and max health 100. So just wanted to show before I go that it should be working in multiplayer as well.